Okay, we are back. This is Math 200. We are looking at Chapter 9 from the Newton notes. We're on the packet 9.3. That is page 4 on your packet. And quadratic formula. So this formula will work for any second degree equation. Any second degree equation at all. You could do this instead of factoring, instead of completing the square, instead of the AC method. You could always just use this, where it's just kind of plug and chug. You take the numbers from this standard form, ax squared plus bx plus c, and you sub them into this equation. So let's take a look at what this looks like. A is 3, B is 1, C is negative 3. Make sure to remember the signs. Those often get lost when doing the quadratic formulas. You gotta be careful about that. So now look, I'm gonna write it out, but I'm gonna leave it blank where I'll insert A, B, and C, okay? And I'll do it in blue. Hopefully you can see the difference. All right, so look, B is 1, so that gets a 1, that gets a 1. A is 3, so that gets a 3, that gets a 3. And C is negative 3, so that gets a negative 3. So we sub those in, substitute it in, and now we evaluate the equation, or plug and chug. I had a professor that called it plug and chug. He was a fun guy. 1 plus 12 times 2 is 36. So good, we like them ugly here. If it's ugly, we get to be done quick. I mean, there isn't a lot of steps. So this one's going to be done quick. 36 plus 1 is 37. So we have negative 1 plus or minus the square root of 37 all over 6. And that's it. We're done. Now, be careful on Newton. They might want this x equals negative 1/6 plus or minus the square root of 37 sixths, like that. They might want you to write it like that. Or they could even go one step further and say negative 1/6 plus the square root of 37 over 6, and x equals negative 1/6 minus the square root of 37 over 6. So this or this or this, any of those they all are exactly the same set of two answers. The plus or minus is just a shorthand. All right, so this one is not in standard form. We're going to move that 1 over to this side. So we have 11n squared minus 9n minus 1 equals 0. And now A is equal to 11, B is equal to negative 9, C is equal to negative 1. And we just plug and chug. Oh, you know what? I said x up there. Oopsie. I guess that was n. I hate it when they change the variables. Just keep it simple, silly. X. But that's n. So this one, is this one also n? This one is also n. So the opposite of b plus or minus the square root b squared minus 4ac all over 2a. All right? So let's take a look. 9 plus or minus the square root 81, because negative 9 times negative 9 is positive 81. Be careful, if you put that in your calculator as negative 9 squared, your calculator is likely going to kick out negative 81. You have to put it in parentheses, negative 9, and parentheses squared. Then it'll kick out the correct answer, 81. A negative times a negative is a positive. Negative 44 times negative 1 is plus 44, all over 22. And so now, what does that play into? Oh, no. So, here, I'm going to erase this one above here. So we need the space. So here, I'll continue this one. So we got n is equal to 9 plus or minus the square root of 125 all over 22. Well, the square root of 125 has a perfect square hidden in there, right? Perfects and leftovers, 25 times 5. So that's 5 square roots of 5. So that is our answer. 9 plus or minus 5 square roots of 5 all over 22. Alrighty. Lovely. Let's get the next one. Okay, so this one, they're really stupid in the book when they do this one. And so we're going to do it in a less stupid way. I think they want to show you that you can just use quadratic formula for anything, even fractions. But why on earth would you put fractions over fractions when you don't have to? And remember, it's an equation, so you definitely don't have to. I showed you this in week 2 when we were solving equations. You find the LCD and multiply every term by the LCDs. The LCD is 8. So this gets an 8, this gets an 8, this gets an 8, and this gets an 8. So 8/8 is just 1x squared plus 8x. That goes into there. 4 times 5 is 20. And 0 times anything is 0. There you are. Use 1, 8, and negative 20. I am not positive why in the world they would want to use 1/8 and 1 and negative 5/2 when this is precisely the same. When you're looking for zeros, this is fine, and we are looking for zeros. So here we go. Oh, good, it's x. So the opposite of 8 plus or minus the square root, 8 squared minus 4ac all over 2a. All right, so here we go. Negative 8 plus or minus the square root of 64 plus 80 all over 2. And 64 plus 80 is 144. So it's actually worse. I mean, it's, I guess, nice that you get real answers. But I'd much rather that was 141, because then we could just circle the answer and be done. Because it's 144, it adds another like 5 steps here. Negative 8 plus or minus 12 over 2. And now we have to split it into negative 8 plus 12 over 2 and negative 8 minus 12 over 2. So we have 4 over 2, which is 2. And we have negative 20 over 2, which is negative 10. Okay. So that's quadratic formula. And avoiding fractions, again, why? I mean, I guess if you saw how the book did it and you're like, no, I like it with the fractions, have at it. I'm not going to ever mark your work wrong if you did it that way, but ooh, I wouldn't do it that way. All right, let's take a look at 4. We got x times x plus 6 equal to negative 30. So we have to do the distributive property, get x squared plus 6x. And we have to move the 30 over to this side, plus 30 equals 0. It's got to be in standard form before you pull a, b, and c. So there's nothing in front of the x squared, so that's a 1 and a 6 and a 30. And now we just plug and chug. The opposite of 6 plus or minus 6 squared minus 4ac all over 2a. X is equal to negative 6 plus or minus the square root of 36 minus 120. Uh-oh, SpaghettiOs. All over 2. Negative 6 plus or minus the square root of negative, right? Negative 84. Ow. All over 2. So 84 has a perfect square hidden in it. What is that? 4 times 21. So let's pull this off out of the side here, off to the side. Here is 84i squared, right? Because it's negative. Perfects, leftovers. So in the perfect bin, we have 4i squared. In the leftover bin, we have 21. 2i square roots of 21. All right, so that's what we're going to replace that with. Negative 6 plus or minus 2i square roots of 21 all over 2. Now, because 2 goes into both of those, I'm going to split up the band. Negative 6 over 2 plus or minus 2i, square roots of 21 over 2. 2 goes into negative 6, negative 3 times, plus or minus, 2's cancel, I square roots of 21. So those are my two answers, negative 3 plus I square roots of 21 and negative 3 minus I square roots of 21. So an interesting little sidebar about these. Before I erase this, when this turns out to be a negative, that means I get imaginary solutions or complex solutions. And so when we're looking in the complex solution realm, we could tell before, like right here, I knew it was going to be complex. So there's this part of the quadratic formula, b squared minus 4ac, that's got a name. That's called the discriminant. The discriminant. And if you find the discriminant and it's negative, that means you're going to get complex solutions. If you find the discriminant and it's positive, that means you're going to get real solutions. If you find the discriminant and it's 0, that means you're going to get one distinct solution. There'll be 2 of them with multiplicity, but it'll really look like just one answer. All right? So let's take a look. They want us, okay, and they're being cute. Plus 12x squared equals 0. Put them in order. 12x squared minus 4x plus 5 equals 0. And so A is 12, B is negative 4, and C is 5. But we're just going to do this part. Okay, so negative 4 squared minus 4 times 12 times 5. Okay, so just that part. So we get 16 minus 240. So that is negative 224. Well, because it's a negative number, I know there are 2 complex solutions, or 2 imaginary solutions. We'll call them complex. All right, so you're just kind of working out this part of the quadratic formula to see if you're going to get real or imaginaries. Because some problems that you might encounter in the real world, you don't want the complex solutions. You might only want real. If you're engineering aerodynamics, you might only want complex solutions and not real solutions. So it's just a quick path to see if you're going to get real or imaginary numbers. So negative 7 and negative 4. All right, so here we go again. Negative 7 squared minus 4ac. And not all over 2a, we're just doing that part, just this part. So 49 plus, it's going to be positive. So you can stop right there. It's 32. And that's 81. And so now you know there's 2 real solutions. And now if you're real sharp, which all of my students are real sharp, 2 real solutions, you might notice that's 81, which means that's a perfect square. So these are going to be rational. They're not going to be, the square root of 81 is 9, and so you'll find 2, I mean, they might be fractional answers, but they won't be non-terminating, non-repeating decimals. It won't be irrational, like the square root of 15 or something. Okay? Okay. Look on the next page. They have the pretty picture. If it's a parabola that hits it in 2 spots, you get 2 positive solutions. If it's a parabola that hits it in 1 spot, you get 1 distinct solution. There's still 2 solutions, but it's called multiplicity. It's like when you have x plus 5 times x plus 5. And then both of your answers are x equals negative 5. But they're in the same spot. And then if it doesn't hit it at all, they're imaginary solutions, 2 imaginary solutions. Okay, so let's look at this word problem. They got it set up for us already with x and x plus 20 and 50. And so there's people cutting across the grass and wearing out the path there. And we want to find out how many feet are they actually saving by cutting across the grass. So it is a right triangle, so a squared plus b squared equals c squared. So that, all right? So we get x squared plus x, remember this is x plus 20 times x plus 20. So that is x squared plus 40x plus 400 equals 2500. Okay. And so now 2x squared plus 40x. We'll move this minus 2500 over. And that's minus 2100 equals 0. We can factor out a 2 and get x squared plus 20x minus 1050, but it's not factorable. So hopefully nobody wasted time trying to look at the suspects for negative 1050. All right, so A, B, and C. So A is 1, B is 20, C is negative 1050. You put that in, you get negative 20 plus or minus the square root of 400 plus 4200 all over 2. And so that is negative 20 plus or minus the square root of 4600 all over 2. And that is negative 20 plus or minus 67.8 all over 2. And then we get x equals, when you do the positive, that's 47.8 divided by 2, that's 23.9 feet. And then the negative doesn't make any sense. It's negative 43, but it's a distance, negative 43.9. But we're throwing that away because it's a distance. So we only are concerned about the positive. So let's go back up to our picture. 23.9 plus 23.9 plus 20 is 43.9. And so when you add 23.9 plus 43, it's 67.8 feet total. And by cutting across, they only walked 50 feet. So the amount that they're saving by killing the grass there is less than 20 feet, 17.8 feet more by taking the sidewalk. All right. So that was a pretty intense problem. A lot of times the real life problems end up not pretty.